Hello everyone, welcome back to Resin Solutions. This is going to be a video about what I believe is the best DLP SLA slicing program for resin printers. And just as an initial disclosure, this is not a sponsored or paid for video, and this software is not free, but I do believe it is worth the price. So I'll go ahead and give you guys the price right off the bat so you don't have to beat around the bush. The price of this program, Photocentric Studio, is around $210 USD. This is a UK company that makes DLP resin printers. They don't do a lot of marketing in the US, so you might not have ever heard of them, but they do make printers as well as the software. And I'm just going to go ahead and show you really quick here why I believe this program is worth $200, and that is if you go in here to the configuration, you select your machine, and you go to Slice Setup. Under the job export format, look at how many formats are supported by this program. All of these formats in here, probably at least 40 to 50 formats, maybe not all individually, but maybe at least 30. All of these formats are supported by this software as export formats. So this software is going to work with a lot of different machines from different manufacturers. I'm using it with an Elegoo machine, the Saturn II. And this here, this .ctb, is what gets exported from Box, or now what they call Satellite. They've changed the name of the software and changed it a little bit, but Box uses CTB files, which is supposedly open source if you Google it, but I think Box did something to it to make it more proprietary, even though it was technically open source to start with. And this particular one here doesn't work with Elegoo machines. It gives you an out-of-memory error, so the structure of the file is a little bit different. But if you go down here and you find the second one, it says CTB version 4 SDK. This version of the CTB file format does work with the Elegoo machines. And the print files do work. So just to show you really quick here, you will have to create your own machine profiles and your own resin profiles. So you're not going to have an easy download like Lychee Slicer maybe, or even Box where you can just download it from their website and import it into the program. You will have to create everything manually. However, I believe it's worth the time because once you create those profiles, you don't have to create them again, and they're just saved in the software. Let me show you a few more of them. You have PNG outputs if you want to do your own printer setup, like an open source printer, which I do have. Build log for if you want to build your own printer. Here's the photon formats. Some of these I don't recognize. Here is the PHZ Sonic Mini. I believe that's Frozen's format. And some of these other ones I don't recognize either, but there are a lot of formats in here, so there's a good chance that if you have a printer, the format will be in here. But the other thing that makes the software so valuable is the fact that the support system is very well programmed and very mature. And what I mean by that is it's very well thought out. So I'm going to go ahead and select this part. We're going to go to the auto support settings right here. It's also up here on the toolbar. I'm going to go ahead and delete all these supports because I have this file saved. And I'm just going to show you guys, if I change this to roughly 100% and just hit auto generate selected, it's going to generate supports everywhere that it thinks that it needs supports based on the critical build angle. And if I turn off supports here for a minute, actually I don't have to turn them off, I can just delete them. You can see that this red highlighting of pixels here is what's called the Z minima, or the critical build angle minima. and that's areas that are unsupported that are going to be at such an angle that they're going to need support structures. And then also the gold is also Z minima as well. So it's a little easier to see if I select the part. But you basically just hit auto generate selected. And if you notice here, the algorithm says creases and surfaces is a strategy. So you've noticed that it puts supports along these bottom creases. This would be considered a crease here. This is a corner or a crease, and it's put supports all along that crease, but it's also put supports along the bottom of the handle here, which is not technically a crease because it doesn't have a sharp edge, but this is considered a surface. So if we change this algorithm to creases only, and then hit auto generate all again, you'll notice that it takes the ones off the handle. So now the only thing the algorithm is targeting is creases. So it's going to ignore everything else except the creases that are needing supports. But you can also go in here and change this to surfaces only, and then it will ignore creases, but it will go ahead and support the surfaces. So usually it's best for models like this to have both, to just leave it at the default, which is creases and surfaces. And then it has surface sampling, which I find random works the best. You can go in here and change it to a grid if you want. And then the strategy down here is split style scaffolding. You can change this to single supports only, lattice support, or cross support. And I want to show you the cross supports really quick. These are cross supports that you can generate them manually as well, but they're basically crisscross shapes. If we zoom in and look at the base of them, we can even look up from the bottom like this. They're crisscross shapes, so this would be a crisscross shape here, this little T shape, and then where they connect to the part, there's actually little connector points in here, these little stems that connect to the part. And it's a very cool, ingenious support type. It's a little bit stronger than your average support, so it could be used to great advantage to support something. And I've never tried them on this particular part to see if the print would succeed. The little joiners here look kind of weak, so they might break off, but anyway, I find that the split style scaffolding, this one here, let's auto generate again. I find the split style scaffolding, which is this right here, where it puts in split cross structures to create stronger supports, is the best for most things. Not all things, but if you had a really big print, you might want to use the cross style. And you can also add that through here. I've added it to what they call the tool belt right here, but it's also on the top layer bar. It's just a cross shape, so I can go in here and click on this. And it says, no, you'll notice at the top it says select 1 to 3 points to add a cross support, enter to apply, escape to cancel. So if I want to add a cross support right in here, I can just go boom, 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 like that, hit enter, and it will generate a cross support. It doesn't touch the model, but it gets very close and supports the model in a different way than your traditional pull support would. So we'll just undo that. Okay, so the next thing I wanted to show you was we can turn off internal supports because these supports up here are not really needed. That part of the model will print just fine at that angle. So I'm going to uncheck this internal supports right here, and the algorithm will ignore the internal supports. And there's also something else I wanted to show you that's super cool about this automatic algorithm. We're going to hit auto generate selected again, and you can see down here the spacing of these is roughly, according to this setting up here, support point distance on the part is 4 millimeters. So you can change that and it will change how far away these are spaced. But rather than place them closer together or further apart, we can actually go in here and change this to something low like 2 millimeters, and watch what happens. We're going to change this to 2 millimeters, and we're going to hit auto generate again, and if you'll notice, it's scaled up to 175% now, but we're not going to change it. We're just going to leave it, and we're going to hit generate. And what it's done is it's generated tree structures, basically what's called a tree support, with most of these support structures. So now we have a connection point or a support every 2 millimeters instead of every 4 millimeters. But we don't have to worry about having more stems running into each other all next to each other because there aren't that many. It actually just split the tips of each one. So you get an increased support count so that you get finer support structures, meaning that this edge is now better supported. It has a better chance of printing because it has so many contact points. There's very little chance that it'll tear away, and it will be a very clean shape. But we also didn't waste a bunch of resin printing a bunch of these little vertical stems because we ended up with 2 for every vertical, roughly. The next cool part about the auto generation is you can see that it's placed supports back here in the handle that we don't need. And rather than sit here and try and delete them manually, which we could do by just selecting them like this, you could select a point or the foot. If we select the foot like this, we could just hit delete, and then delete, and then delete, and it gets a little hairy because you start having pieces left over. And then you've got this connector hanging off. And you can see we deleted them, but it took a bunch of steps. The easy way to do it is to just click Edit All. And once you go into edit mode, you have these little spheres showing you where a contact is going to be, and you just click on it to remove it. And so all we're going to do is we're going to shift. We're going to hold shift, left mouse, and we're going to drag with the left mouse, and everything that's inside of that box will be erased. So we didn't have to click a bunch of times. We just shift left mouse, and then we erased them. So I'm going to clean this up a little bit. So we're going to do the same thing. I'm going to erase these, and then shift left mouse these. Boom. And then we also need more supports in here, and the easy way to place those supports is to simply click again. If you click in an area that doesn't have a support, boom, it just adds a new support. So we're going to add some new supports in here. Everywhere you see that little ball, there's going to be a new support. Going to go over here and add more because this needs support. And then this surface down here is going to need some supports too to survive. So we're going to put some down here. Maybe like that. And then on the back side here we also need some supports in here to keep this structure rigid while it's printing at an angle so it doesn't move around too much. Place some supports in here, maybe one there, there, and there, maybe one more here. And now when we go out, we hit enter, you can see at the top here it says to click and add points, enter to apply, escape to cancel, so I'm just going to hit enter. And then if we move back over to here, you can see that we've deleted all the supports we didn't need, especially these ones on the back of the handle here. But now we've got new supports over here that's supporting the side of this opener. And then also in here we've got some supports. So if we cut down through this part here with the little layers preview, we can see that as it's printing upward at an angle, if you watch the red here on the left, watch this red area here, as it goes up at an angle, there's constant support giving it support so it can't twist around and break off as it prints. Because we want these two halves while they're printing to come up and meet each other and not have misalignment. So we've got this part of the print and this part of the print here over at an angle, and it cups around here. We want these two parts to come together without any misalignment, so that'll make it work right there. And the other cool thing is you can edit these supports manually. So if you zoom in here and you don't like the way this shape is right here, like let's say the angle of this support is not right, we'll just click on this little thing here, grab the manipulator, and we'll just move it down. And it's that simple. You just edited the support. You didn't have to do anything fancy. You didn't have to change modes. You just click on it and you edit it. The only other thing you might want to look at that I had to set for this particular model, if you'll notice these little spheres, the contact spheres, are placing the joint outside the model, and I wanted that on purpose so that these will snap off without leaving voids in the model. You can go right here to part connection, and you can make sure that the tip contact depth here is at 0. And this tip beam diameter here, 0.76, is the diameter of the tip right here behind the sphere. So up here, when you have the tip diameter, where it says 1, that's actually the diameter of the sphere itself, not the tip of the support. So you're going to go into here, this part connection, set your tip diameter to be whatever you want, and then you can set the sphere to be larger, so that way you know that when you snap these supports off, they're not going to break off and take a chunk of the model with them. So yeah, that's pretty much it for the auto supports. In a nutshell, obviously there's a lot of settings here. I have absolute foot size turned on for the base plate, the little bases here on each one. I've changed a couple things in there. But overall, that's pretty much it for the auto supports. If you want to add a manual support, you can literally just click and add it with the right mode. So we can click right here, add single support. Every time we click, it'll add a new support. You can see them being added there. And if we want to save the settings in this panel, these settings here are for the single support only, not for the auto supports. So when we have the single support selected, these are the settings that we want applied to every one when we add it. You can just hit Save Current and it'll save it to the profile that you have right here. Every support structure that you use in the program, there's a panel of settings for it, and you can always modify those settings and then hit Save Current, and it will save it to that current support profile set, so that you can always use the same settings every time. You don't have to keep coming back and changing them every time you load up a new program or a new project. So yeah, that's basically the value I believe in the software, is the support structures. I did want to show you guys the lattice structures really quick. And I'm going to hit lattice up here. And the lattice support structure is so cool because you can have a lot of contact points on something that's really going to need a lot of support when it's printing. And I'm just going to show you guys by putting a lot of supports right here in this section of the model. You can't see where I'm clicking too much except for the highlight in my screen recorder because these little spheres are so tiny. Here you can see them where I placed them. But we'll say that this here is good, and then when we hit enter, you can see that it's added a very dense lattice structure, and it's placed a contact point everywhere we clicked. But the structure is built in such a way that it's cross-reinforced in almost every direction. So those supports are very, very strong compared to the other styles of supports. So some styles might break when you're printing. If you have a really large part that's pulling sideways on them, it might snap the supports while it's printing, and that's when you would need the lattice support. So that's a lattice support. And the one of the support I wanted to show you was the tree supports. So we're just going to undo that. And I'm going to add some tree supports here under the main portion of the handle here. So I'm just going to go click, click, click. And I'll put one more here and just hit enter. And that's a tree support. And it's nice because you can get multiple contact points without having a pole for every one of them. It starts to get a little cluttered, and it makes the resin, makes you waste more resin too. But I don't like this joint so low here because it's got a weird angle and it's going to break while it's printing, so I'm just going to pull the joint up to about here. And I'm going to drop this joint so that the angle of that leg is not so steep. And yeah, there we go. I think that's a nice tree support. So yeah. And also down here in the corner, when you're scaling down through the layers of the part and the support structures, you can see that you have the option of layers. You can click this one, which will show you resin usage. So if you see right here, it'll say, I can't move my mouse, but on the left you'll see it says 62 milliliters, and it says support 0%, and price is $269 USD. So because we don't have many supports right now, it's not showing a value for the support structures. But if I go back and add all of the support structures, you would see a value there for the supports as well, and it'll show you a total cost. Or you can click on this, which will show you the time that the print's going to take at that given layer height. So as we scroll down, it doesn't change the total time there, but that just gives you the time. It shows 5 hours and 1 minute right here. Or we can go over here and just click on this, and it'll show us it's 1,599 layers. This does have the option up here to add drainage holes. It does have a remesh engine that will remesh your mesh. It's called a shrink wrap function. It has a reduce mesh, which will reduce your mesh if you have too many faces. It has a hollow function that will hollow out your model. And it has an infill function here that will place a lattice inside your hollowed model. So if you had like a miniature, for example, and you hollowed it out, then you could add this lattice inside to strengthen it a little bit. But it still would take much less resin than if you'd printed it solid. So these are really nice mesh tools up here. I can't go over all of them because the video would be way too long. But there is a 30-day free trial of the software that you can download from their website to try it out. And now I'm going to show you guys how to add your own machine and resin profiles. So you're just going to go up to File, Configuration. You're going to click on this machine highlight here. And you're going to hit the plus button. And it's going to say we're not connected to the internet. And we don't care. All machine types. We're going to go to Other Machine Types. And you're going to select Default DLP Printer. This SLA printer here would be if you had a moving laser projecting through a screen, and we don't in most cases. Today we're going to have a backlight projecting through a screen, which is a DLP. So you're going to select DLP, turn off this. We don't need to download additional data. So we're just going to click on that, and we're just going to hit OK. And you can see it just comes up as a default DLP printer. And the most important thing probably is naming your machine the exact name that it is named in your slicing software that's designed for the printer. So in other words, if you bought a Elegoo printer, you would go to T2Box and you would get the name of the printer. And I'm going to show you really quick here. We're going to click on this printer. Down here in the machines now, we're going to click on Default DLP Printer, and we're going to change right here where it says printer name. We're going to go over to T2Box, and I'm going to show you right here. If we go to the settings, this is the profile that we downloaded for the Elegoo Saturn II, so we know all the settings are correct. Notice here that the name says Elegoo Saturn II, and over here it says Elegoo Saturn II, the same thing, but it's all capital. And so is this one. They're all capital. So everything in the name has to be identical, or when you go to load the printer files onto the printer and print them, the printer will say that the machine is not recognized and it won't print. So we're going to go to the configuration here. Sorry. I don't know why I changed my panel, but we're going to go here. And we're going to change this with the cap lock. We're going to put Elegoo Saturn 5, and then we'll put 16K. I don't even know if that's the right resolution, but that's what we're going to put. So if that was the exact name of the printer, then it will work. So we put that first, and then you're going to copy over everything else. So these resolutions here for the pixels and the size X, Y, and Z here, you're going to copy that to these values here. So here's your X, Y, and Z in millimeters, and in your pixels, X and Y. So you're just going to fill these values out just like they are from the other software. We're going to leave the draw machine platform on, because that's going to show this green, which is your platform. Automatically center is going to center the parts when they get imported, so we'll leave that on. And we're just going to skip over here to the print profiles, and we're going to go to the slice setup. Most of the stuff in here you can ignore, but we're going to change the slice setup to be the file format we want. So on this one, we're going to change it to the CTB version 4. And then we're going to go to the print profiles, and this is where you set up your resin. So we're going to just edit this resin. We're not going to add a new one. If you wanted to add a new one, you can just hit the plus here, and you can keep adding as many resins as you want. But we're just going to double click on this 50 micron here, and this is our resin. We're going to leave this on single layer thickness. Going to go to movement and exposure. This is the most important tab. We're going to click movement in 2 stages. I'm going to change the bottom layers to about 6. Transition to be 6. And then if you'll note, this box here where my mouse is tracing, it says normal layers right here. And in this box over here, it says bottom layers. So we're going to do the normal layers first. This graphic down here shows you how the layers are going to be set up. And it shows you that we're moving up right now 5 millimeters at 50 millimeters per minute, and then we're moving down with this other arrow 5 millimeters and 50 millimeters per minute. So we're going to change this first value to a 2. We're going to change the second value here to a 5. Oh, I'm sorry, we're going to change this to a 5. Yes. I was correct the first time. We're going to change this one here. Just need to double click this so it highlights everything to a 5. And don't hit enter because it will do that. But never worry, the settings are still there. So come back in here. So we have a 2, a 5, 5, and you'll see this is automatic because this is the return. And it's automatically calculated because it has to subtract the thickness of a layer slice. So it just says 2, but it's actually less than 2 millimeters by a little bit. So if you'll notice now, the graphic has changed. Remember before, there was only one arrow going up and one arrow going down, like this page over here shows. But now you can see there's actually 2 arrows going up and 2 arrows going down. And the reason for that is because we split the movement with this click button up here into 2 stages. So it's going to move 2 millimeters at 50 millimeters a minute speed, and then it's going to change and move 5 millimeters at 1 millimeter a minute speed. And we don't want that, so we're going to click this because 1 millimeter a minute is super slow. So we're going to click this box here. We're going to change this to 400. I'm going to double click the bottom one. We're going to change that to 400. And we click out here somewhere, that'll save, or we just click in with their box. Okay, so here we have the correct speed. So 5 millimeters at 400 millimeters a minute, and then it returns downward 5 millimeters at 400 millimeters a minute, and in the last 2 millimeters it slows down to 50 again as it goes back into the resin. So we don't want it zooming into the resin and splashing everywhere and creating air pockets. So these are some good settings to start with. And you could put them obviously to be however fast or slow you want, but just remember, the slower they are adds up really fast. When you're doing thousands of layers, your print will get a lot longer. So we're going to go over here to the bottom layers. We're going to change that to be, I'm going to change this value to be 4. And I'm going to change this value to be 3. And then we're going to change this one to be a 3. I'm going to change this one to be 400. And we're going to change this one to be 400. And if you'll notice, you can't see the zeros in here because for some reason in the UK they can't figure out how to program a box wide enough to show the number system. But yeah, I don't know why these boxes are so narrow and there's no way to change their width. So a little bit silly, but just look for the decimal place or look at the graphic here to make sure you put the right speed in. That is something to be wary of in these other settings, like for example the exposure time. If you have an extra decimal point over here underneath the arrows that you can't see, then obviously your print's going to be way off. So definitely click on this field and arrow over with the arrow keys and make sure that you don't have any extra decimals in there. I'm going to turn off the rest time here, so I'm going to double click in here and change this to 0. Oops, sorry guys. I hit enter again. Not an American program. We'll change this to 0, but the exposure for the bottom layers I'm going to change to be 50,000 milliseconds, which will be 50 seconds. Let's just make sure we've got the right amount of zeros. So 50, there's 50, 0, 0, 0. Yeah, so we've got, yes, so that's 50,000 milliseconds. And then this transition layers here is how many layers happen between these initial 6 layers and the rest of the layers in the print. And the transition means that it slows down the exposure gradually so that you don't jump from 50 to 4. Otherwise you would have jumped from this 50 right here, 50 seconds per layer for 6 layers, right? Because we have 6 bottom layers, and then it would all of a sudden jump to a 4-second layer. And we don't want that because the part might break or fail there. So we want at least 6 transition layers, maybe even 10 might be a better setting here, but I don't want to waste time, so I'm going to leave it at 6. And the 6 will transition slowly from 50 down to 40, down to 30, down to 20, down to 10, down to 15, down to 4. And that way it won't break the part. But yeah, that's pretty much it. We've set up everything here for the resin and the movement of the machine. And if you'll see here, I forgot to show you this a minute ago, but now we have 4 millimeters at 50 millimeters per minute. And then at the top, we have 3 millimeters at 400 millimeters a minute. So why did I put this at 4 instead of 2? The reason is simple. I want the platform to move slower in the resin when it's doing the bottom layers, because it's going to be further down inside the resin anyway. So I don't want it zooming around. I want it moving nice and slow and making sure that everything peels off the vat film nice and clean. So yeah, we're done here with the resin except for the name. So we're going to change this to, we'll just change it to custom Elegoo resin. And then you can change the price up here per liter. This will change how the program shows you the price of your part. Change this from euros to USD because that's what we're buying it in. And then you can change the color here. We're going to leave it gray. And this is the density in gram per millimeter, or sorry, per milliliter, to show you the price of your part accurately. And that's pretty much it. The pre-processing here, you don't really need anything in here. The post-processing, you can come in here and enable anti-aliasing if you'd like. I leave mine off, but if your parts are not fitting together, if you have a 0 tolerance part and it won't fit in the other part, then you'd probably want to put this on high, and that'll make the parts just ever so slightly smaller because of the anti-aliasing algorithm. And then you can also turn on 3D anti-aliasing, which will anti-alias between the slices, which is pretty cool. Not all programs have that when it comes to slicing. But we'll just leave that off for now. So the main panel is this panel, getting everything set up. And I would recommend run a dry run with no resin and take the vat, or sorry, not take the vat, but take the platform off. And just run the machine with no resin, no platform, and just make sure that everything is moving at the right speed. And once you know that everything's moving at the right speed and it's operating correctly, then you can say, okay, now we'll put the resin into the machine, because I did have a problem where one of these values was a 1 millimeter per minute, so it would go up and then it would slow down to 1 millimeter per minute, and it was so slow that you couldn't actually see the platform moving. So yeah, do a dry run first. Now we're going to hit OK. So that saved the print profile. This, you need to set this up, obviously. I went over that earlier. We didn't set it up because we're not trying to waste more time. And then you want to make sure you have your format correct here. And you hit save and close. And that was basically the basics of the program. One last thing before I go. Here's the competitor, really, for nice features, and that is Lychee. However, Lychee takes all the nice features and hides them under a rent your ass off plan. This is around $12 USD, so you figure $140 roughly for a year, and you own nothing. You rented your car, you got back and forth, and you own absolutely nothing to show for all your money. So rather than waste your money on a rent program that gives you nothing in return, basically, why not spend the same amount of money for 2 years, or a year and a half actually, of Lychee, and just buy Photocentric Studio outright, have your license for 2 PCs, and it's a perpetual license, so you get free updates. That's pretty much it, guys. Hope you enjoyed it. My next video is going to be about a new resin cleaner that I stumbled on. It's not actually a resin cleaner, but it works awesome as a resin cleaner, and it's very cheap. So stay tuned if you want to see that video.